So, who are we looking for again? This guy named Dmitry Mendeleev. Why is he so important? What do you do? Well, apparently, I think he's the father of the modern periodic table. And what was the package that he had? It was strontium.
Yeah, I don't know how many enemies there are around here, so just be careful. Come here. Let's go in here.
I'll clear left.
Okay.
So where is everybody in here even?
I don't really know.
We got a man down. We gotta get out of here. Oh, boy, man. Stay right here. I gotta clear the area.
Billy, stop right there.
Mosley, get the other one!
Hello! I brought you here to teach you about chemistry. Are you ready?
No. Yeah.
That's the spirit. All right. So here, we have the periodic table. Now, I created this beauty myself. I predicted many elements. Some may call me a genius. But anyways, enough about me. So some basics about the periodic table. First, we have the metals. Everything on this side of the table, metal, except hydrogen. That little bugger's over here. But it's a non-metal on this side. Everything right over here. Non-metals. It isn't on here, but there's a little stair-steppy line thing. And that separates the metals and the non-metals. Now, there are some strange elements in between. We call them metalloids. So, anything that's touching the stair-steppy line thing. We have boron and silicon and arsenic and tellurium and actinium. And everything below it. Polonium, antimony, germanium, aluminum. But there are two exceptions. Two dastardly metals. Aluminum, polonium. They're metals. Remember this. Remember! Alright, so next, class, we have the groups. Now, the groups all have a number, but they're also divided into smaller groups that are just these lines. So, the first group is right here. These are the alkali metals. Then we have the alkali earth metals. Different, you see. Different. These ones are very, very reactive, for they only have one valence electron. Now, in the middle here, this is all one big group, called the transition metals. However, there's a strange little group right down here, and all these are the inner transition metals. And we also have, these two groups are broken down into their own groups, the lanthanoids and the actinoids, right at the bottom. Alright, next we have the boron group. Exciting, right? I wasn't responsible for the name of that one. Then the carbon group, and you. No. What do you think this one's called?
Nitrogen group.
Yes, of course! It starts with nitrogen. Yes. However, this group is the strange one. This one is the chocologens. Yes, chocologens, you see. Very strange, Alright, and the next group right here, it starts with fluorine. Now, what do you think that one's called?
The fluorine group, sir.
No! No! Not the fluorine group that ended with oxygen. Because this one has a special name. These are the halogens. The halogens, remember. Remember the halogens. Because, like the alkali metals, they are very, very reactive. They want to become stable like the final group. This group is called the noble gases.
This must be the class. Excuse me.
Yes?
Would this happen to be Mendeleev's class?
Of course it is.
It shows. Your periodic table is atrocious. I can't believe that you had arranged them like this.
What are you doing? Stop! Hey!
No!
This is my classroom!
No, this is mine now. This is my classroom, and if you get mad at me rearranging something for one more thing, I'm just gonna leave this chemistry class. So now, let's teach them about the trends. Sarah, now Noah, do you know any of the atomic trends?
I think one of them is called ionization energy, but I'm not sure what it does.
Very good. Mendeleev, I'll let you take it from here. Be careful.
Alright, so, to give you a few of the trends. One of them is electronegativity. Of course, ionization energy was very correct.
Yeah.
I'm impressed. We also have atomic radius. Of course, electron affinity. And, Mosley?
Now, the next one would be successive ionization. And the last one would be ionic size. But don't get this mixed up with atomic radius. And to explain one of the trends, atomic radius, it will decrease when going from left to right across the periods, and increase going down the groups. So down here by francium, you would find your biggest atomic radius, and over here by helium, you would find your smallest. This is because the less protons that are in here have a weaker attraction to the larger shells than they do over here, making it smaller.
So, next, we have electronegativity. Electronegativity is similar to many of the other trends, which increases as you move down here, and decreases as you move down the group, you see. That's different than atomic size. This reasoning is because all the different elements right here have 7 valence electrons. So they want to get one more, and they attract more, because electronegativity is the ability of an atom to attract another electron. That's what it wants to do. It wants to become stable and become into what the noble gases states are, which is completely stable.
Now, Mendeleev, if you wouldn't mind, I'd like to teach him about one more.
If you don't rearrange it.
Do as I please, don't give me this mockery. Now, one last one I would like to show you is electron affinity. And that is when an atom gives us energy when it receives an electron from a different atom, becoming an anion. Now, this trend also increases along the periods, like many others, and decreases when you go down the groups. Now, the other atom that it receives it from becomes a cation, and that's a positively charged atom because it's lost an electron. Now, class is dismissed.
What's that mean? What are you doing? Hey,
No.
Noah!
What's
Noah!
that?
No! Where are you taking him? Oh, no!
That's all.
Now check. Now stay there. And don't move until we say so. Let's get down.
Are we gonna die?
I think we'll be okay. We know chemistry now.
Yeah.
Here, I got mine off. They're leaving. Be quiet.
Get out of here.